I do not feel I'm exaggerating when I say that the discoveries of the telescope are to be regarded as the most important ever made in the history of astronomy. These were the words of Galileo Galilei, written over 400 years ago in Sidereus Nuncius. He had just witnessed what no human had seen before: mountains on the moon, stars too faint to see with naked eye, and four moons orbiting Jupiter. What he saw through his telescope unlocked the secret of universe, but it also came at a great cost. Galileo's discoveries defied the beliefs of his time, challenging a worldview that placed Earth at the center of everything. For this, he faced trial, was sentenced to house arrest, and spent his final years blind and suffering from fever until his death. When I think about Galileo, I can't help but wonder what gave him a courage to keep going on, even when the world turned its back on him. Maybe it was his unwavering belief in the power of telescope to reveal truths that no one else could see, and he was right. Our journey begins in the Netherlands in 608 when a glassmaker, Hans Lippershey, tried to patent his instrument, describing it as for seeing things far away as if they were nearby. However, just a week earlier, another Dutchman, Jacob Matthews, had filed a similar claim. The government, seeing how easily the device could be copied, decided not to grant a patent. But Lippershey wasn't left empty handed. He was handsomely rewarded by the Dutch government for providing copies of his design. The telescope uses two types of lenses, a convex lens and a concave lens. First, the convex lens, it curved outward, like the shape of a bowl. When light passes through it, the lens bends the light inward, focusing it onto a single point. This helps gather light from distant objects. Next, the concave lens. This lens is curved inward, like the inside of a spoon. As light passes through it, the lens spreads the light outwards, which help magnify the image. This makes distant objects appear larger and clearer. In a telescope, these two lenses work together to help us see distant objects clearly. The convex lens at the front of the telescope gathers light from far away objects and focuses it into a clear image. Then, the concave lens at the other end of a telescope takes that focused light and spreads it out, making the image appear larger and easier to see. But there were some problems with this first design. Because the lenses were not made of the best glass, images could sometimes look a little blurry or distorted. There was also an issue called chromatic aberration, where the lights bend differently for different colors, causing a blurry rainbow effect around a bright object. Initially, the telescope used for military purposes and sport distance, but this was soon to change. 1 year later, Galileo came up with his fabulous telescope. He replaced the basic lenses with higher quality glass and carefully shaped them, which gave him clearer and more accurate images. This design also provided a magnification of up to 20x, a huge leap from 3x magnification of the original design. What made Galileo so special is that he used the telescope to look at the stars and the planets. His discoveries offered a new view of the universe, which led to a clash with the church and ultimately to him being sentenced to house arrest. Even with all his advances, Galileo's telescope still had problems like color distortion and a narrow field of view, which limited what it could do. In 1611, Johannes Kepler introduced a groundbreaking telescope design in his book Dioptric. Unlike Galileo's telescope, Kepler suggested using two convex lenses, a convex objective lens and a convex eyepiece. This design created a larger field of view and higher magnification compared to Galileo's telescope. Light from a distant object enters the telescope through the first convex lens. This lens focuses the light to a point inside the telescope, forming a real image. Then, the second convex lens, the eyepiece, magnifies the image so it appears larger and clear to the person looking through the telescope. Initially, Kepler's design was not widely accepted by astronomers, but in 1630, a German mathematician Christoph embraced the idea and published his book Rosa Urgina. Using a Keplerian telescope, Christoph conducted detailed studies of sunspots, demonstrating the advantages of this design. The Keplerian telescope, later known as the astronomical telescope, flipped the images upside down. But for studying celestial objects, this was a minor drawback compared to its superior brightness and expanded field of view. In the 1668, Isaac Newton, after studying light and optics, discovered that the refracting telescope had a big problem, chromatic aberration. To fix this, Newton decided to use mirror instead. This idea was first proposed by Scottish mathematician James Gregory in his book Optica Promota, but it was Newton who made it a reality. Light entered the telescope and hit a curved mirror at the back. The curved mirror reflected the light to a point inside the telescope. Then a small flat mirror, angled at 45 degrees, redirected the light to an eyepiece on the side, so the viewer could see the image clearly. Newton's reflecting telescope was not only more compact, but it also provided clearer and more accurate images. That's why it became the blueprint for modern telescopes. After Newton's groundbreaking design, the pace of telescope evolution skyrocketed. In 1789, William Herschel built the largest reflecting telescope of his time, with a 1.2-meter mirror that revealed unseen wonders, including new moons of Saturn and Uranus. In 1931, Carl Jansky discovered radio waves from the space, leading to the invention of the radio telescope. Unlike optical telescopes that collect visible light, radio telescopes detect radio waves emitted by celestial objects. Here's how a radio telescope works. A large parabolic disc collects radio waves from space, focusing them onto a receiver at the disc focal point. The receiver amplifies these weak signals, which are then processed into a data or image for analysis. Radio telescopes have unlocked the secret of the invisible universe, revealing phenomena like pulsar, quasar, and the cosmic microwave background, the faint afterglow of the Big Bang. It's amazing how something as simple as tube and two lenses changed everything, opening a universe we never knew existed. And honestly, it all started with curiosity. The kind of curiosity I hope we all have. If you are still with me, I know you are just as curious as I am, and I appreciate that. If you want to know why rocket don't go straight, you can click here and click here for more cosmic colors. And thanks for joining me on this journey.